Okay, I'm going to tackle the Linda problem, which is a very famous problem in psychology, made famous by two psychologists, Daniel Kahneman and Amos Tversky. So, here's the problem. Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti nuclear demonstrations. Which statement is more probable? Linda is a bank teller. Number two, Linda is a bank teller and active in the feminist movement. Let's go through let's go through it. So this is a problem of joint probability. If you guys know about a set theory, um, two events happening at the same time, simultaneously, right? Let's say bank teller. Linda is a bank teller. The probability of Linda being bank teller, let's say PB, right? There's a whole set. There's another set. Probability of Linda being feminist, active in the feminist movement, is given by probability of F. Now, we are trying to see which one is bigger. Is Linda a bank teller or Linda is a bank teller and active in the feminist movement? Here, the question number two is asking this area right here. Question number two is asking uh, the area overlapped between two sets, bank teller versus active feminist. So, which is given by P, probability of bank teller intersection feminist. So, which one is smaller? This overlap is smaller than the probability of being bank teller. It obviously says that the intersection of two sets is always either smaller than the individual set or equal to. Maximum is equal to. It could be the whole set. Both things could completely overlap. But here, they do not completely overlap. So there's a small intersection of the bank tellers who are happen to be feminist. Let's even illustrate this with a 2 by 2 contingency table. Here's the table. Let's say there are 10,000 women called Linda in the United States of America. So 10,000, um, last row, last column, 10,000. Now let's say there are 2,500 bank tellers. Out of 10,000, there are 2,500 Linda who are bank teller. Also, let's say there are 4,000 Linda who happen to be active in the feminist movement. Now, as you can see, row is for bank teller or not bank teller. There are 2,500 bank teller Linda, and there are 7,500 non bank teller. Also, if you look at the column feminists, there are 1,000 feminists who are bank teller, 3,000 feminists who are not bank teller. Second column says there are 1,500 Linda who are not feminist, but they happen to be bank teller. There are 4,500 not feminist Linda who are not bank teller either. They have completely different job. Uh, they don't work as a bank teller, and they are not feminist. It's completely out of the equation. So we have 4,000 feminists, 6,000 not feminists, 2,500 bank teller, and 7,500 not bank teller. As you can see, the joint probability is the one, the first row, first column, 1,000, which intersects feminist and bank teller. Make sense? So 1,000 Linda who happen to be bank teller as well as active in the feminist movement. But there are 2,500 Linda who are bank teller. Right? There are 2,500 Linda who are bank teller. Here, the first Venn diagram. There are 1,000 and there are 4,000 feminists. The second Venn diagram. And where is the intersection of feminist and bank teller? There are 1,000 bank teller who happen to be feminist. So this overlap is the option B. The Venn diagram, the first Venn diagram is the option A. So option B cannot be bigger than option A. As we can, let's calculate the joint probability. Probability of being bank teller equals how many total bank tellers? 2,500. How many total Linda? 10,000, which is 25%. All right. Probability of feminist being feminist. There are 4,000 feminists out of 10,000 total women who are named Linda. And we have to, when we calculate joint probability, this is a case for dependent. This is not independent event. There is a overlap between bank teller and being feminist movement, being active in feminist movement. So the formula for P, probability of B intersection F being in the same intersection, equals probability of bank teller times probability of being feminist given she is bank teller. All right. So probably being bank teller is 2,500 over 10,000 times probability of being feminist given C is bank teller. So we have to look at only the space for bank teller. Out of 2,500 bank teller, given 2,500 bank teller, how many are feminist? 1,000. So if you do calculation, it will be 10%. 10% of people are, 10% of women, Linda, are bank teller and are active in the feminist movement, whereas 25% of the women who Linda are banker. So it definitely proves that probability B is smaller than probability A. So the chances of being Linda being banker is more than chances of being Linda being banker and active in the feminist movement. Thank you.